The Haney test, hand the Haney test guide sheet out now. I'm going to show you how to read the new technology of the soil test so that we can save you money right off the top of the bat right now without you doing anything, 10 to 20%, and not even changing anything. I'm going to show you how to read your own test. I provided a guide sheet. Then later this evening, right after, if you want to leave, that's fine. I'm going to talk about some grazing that's done in Mexico, how they're turning the desert back into prairie, and it's amazing, and how we can talk about that, how powerful animals are in the system. And we'll do that later on, but if you guys want to escape by then, that's fine. But first, Martin, where's Martin at? Martin, thank you so much. You said your whole presentation was great, because here's what I love about when I come and teach with a producer. And I'm glad you guys did that. You guys can call and listen to me and say, yeah, Ray, it's great. I think you're strange, bizarre, go away. It still don't work here. But when Martin comes here, if it's local, says, hey, I'm making it work and I'm making it and it's working for me, that says so much. That means so much. And Martin I love Martin that you said, you don't have to all have these fancy tools to make it work. That was very powerful. Another thing that struck me, because you brought connectedness in, I think we forget when you said that corn is very connected to ethanol, and electric cars are going to spread all over the country. And what is that going to do with corn? Quick thing, you think about if all of us were diverse in our cropping systems, prices would sustain and maintain and would be higher. But what do I hear most producers, man, but I want to do 300 bushels. Then it lowers the price more and more because everybody seeks the goal and they're always looking for the panacea. The panacea is making money. Yield is not equated to making money. 270 bushel corn in Arkansas last year, pivot, farmer made no money. I had a 2,000 acre a farmer in Iowa. He said, Ray, last year I made zero money when he paid all the inputs. I said, wow, you would have been better growing a pumpkin patch and selling pumpkins at the edge. You would have had less risk. And that's the thing that's not sustainable. So just to give you a comparison, what's the difference between the word sustainable and regenerative? Sustain. Look, I'll use Lance. I said, Lance, his wife's Christy, right, Christy? Lance? I say, Christy, how does it feel to be married to Lance? It's sustainable. Life sucks. But what if I said, how does it feel to be married to Lance? Oh my goodness, it's regenerative. Renewal. I wake up, roll over and see that man and I go, oh, there's a renewal of my love right there. Always growing, always getting better. The word sustain is ridiculous. We got to regenerate, then sustain. Your body regenerates every day. Always developing, always getting renewal of cells. That's regenerative agriculture. See the difference? Huge difference. I don't mind. Sustain was a long time ago. I know some of the old hippie guys said, Ray, got pissed off because I used that word. Words mean everything. It's the way we communicate. Regeneration is what we're talking about here. Now, beneficial insects. Please understand that 1 inch of soil, over 70% of the insects make their home and cycle through the soil. So if you're disking it, you're tilling it, where's the beneficials? To control all the insecticides and pesticides you have to buy. That 1 inch is critical. To me, if I can't get the water in that first inch, I don't care about the other 7 feet. Most of it will run off. If it's not aggregated in the first couple inches, water will not go in. That's the habitat of all these organisms. 1,700 beneficials for every one pest. Self-regulating. Nature regulates its own weeds. regulates its own pests. What happens when we're out of balance? It doesn't regulate anymore. That's what happens. Now, when we roll these cover crops down, we are mimicking the forest. Brilliant. Lay it down. There's a reason the forests are always covered with that beautiful mat. Not only does that mat protect that 1 inch of soil for all those organisms, it feeds them, it regulates temperature, it suppresses weeds. Best cover crops are rolled, and you can see it prevents crust. Where there's rye laying on that top of that, or rolled cover crops or a living plant, no crust. No crust. I can walk in any field conventionally, and when there's bare soil, crust, even in no-till. That is a living skin. That's the thing. Now, how do we determine about cover crops? Why do we get so wound up and so excited about cover crops? It was Dr. Edmir Caligari went to the no-till in the plains. Jay Fuhrer, Gabe Brown, in 2006 went and listened to him. And I remember when Gabe said the first time he heard him, he says, yeah, donkey, I get it. We mimic the prairie. Our cover crops mimic the prairie. That's what this is. We're trying to mimic the prairie, and we're using this type of species that we use. Case in point, there's a book called Farming in Nature's Image by Dr. Piper. It was a very interesting book by the Land Institute. I'll never forget, I think it was page 140. Don't hold me accountable to that. I'll never forget what I learned from there. I highlighted, I go, wow. Scientists went into a tropical forest, took it down, planted corn and soybean. What's the first thing happened? Carbon cycle went down, nutrient cycle went down, the system fell apart. So the scientists went back and says, hey, what if we put the crops that we love to eat, papaya, banana, coffee, and mimic the architecture of the tropical forest? Guess what happened? Carbon cycle went up, nutrient cycle went up. What I learned, just because it doesn't look exactly like prairie, it's the architecture. It's the design that brings the function. Okay, now I'm going to put a little quick pause. What are the four processes that we talked about this morning that needs to happen in every square inch of your farm? You guys remember? Capture sun. What's the other one? Water cycle. How do I know the water cycle is working? I better check aggregates, and if it's running off that land, if it's not aggregated, water cycle is not functioning. What's the third one? Nutrient cycle. No water, no microbe cycling. How do I know the nutrient cycling is working? You're buying a lot of fertilizer. Got a lot of weeds everywhere. Good indication the nutrient cycle is not working. Too much manure, too much cost. Your costs are high. Diversity is what did I call it? Anybody remember? Remember how I compared the cell phone? What is it? It's the what of the planet? The software of the planet. It runs everything. 4 processes. Look at your field. You got to capture sun, water cycle, nutrient cycle. Diversity never stops. Never stops. It's got to happen every day on your farm. If you're not, it's costing you money. Now, why did we come to this design? Let's go to it. Dr. David Tillman, you can find his research papers. Well worth reading his papers. In fact, I think the research was done in Minnesota, by the way, Dr. David Tillman. Here's what's really cool. Because what I do is, okay, I saw Dave, Gabe, and them. I said, well, let me see if I find any literature. Because my goal is to mimic the prairie or the forest. So that's my template. So I said, okay. So I use this concept here for doing our design of my mix. On here is plant biomass. Here is species diversity. Notice, when I put 5 species, from 5 to 15 species in the mix, look at the biomass increase. What is that called? Synergy. 1 + 1 is not 2 in natural ecosystems. 5, 11, 10, 12. I want to tap in to that power. Diversity. Only diversity can do that. Now, there's another part of it. Functional diversity. What does functional diversity mean? Each plant is there's functional groups. Grasses is a functional group. Broadleaves is a functional group. Legumes are a functional group. Shrubs are functional groups. Those are different functional groups. I want as many functional groups in my mix. Look at this one. 3. Boom! Synergy. What did, Martin, you said you had some legumes, right? You had some, look at his mix. Broadleaves, legumes, grasses. But my foundation is my grass. That is the foundation of my mix. I start with that first. Then I add. It's like making a cake. But I design mixes. You don't throw seed to throw seed. First, there's a book you all have to get. It's called Managing Cover Crops Profitably. Managing Cover Crops Profitably. You'll find it on PDF. It's free. Or you buy the book for 20 bucks. Know what each plant does. Don't be throwing seed to throw seed. It's expensive. And if I was you, I'd grow my own cover crop seed because you can run the combine, create your own mix, put it in there, boom, you got it. Make your own mixes. You don't have to buy them, but if you don't have time, buy them. I'm not telling you one way or the other. Now, let's go back here. Now, let's see. Now, let's go to how some of these practitioners all over the country, and I like to pick on Rick Clark because Rick is he's a pretty amazing guy. Let's see what Rick is doing in Indiana on 7,000 acres organic no-till. Why do I bring that out? Organic farmer says, there's no way you can do organic no-till. It's too hard. And I would say, you're right if you're not the right producer. Organic no-till is very hard. Think about the tools you have for weed control. That's the bear. Rick is making it work. What makes Rick different? That man does not take no for an answer. Now, he's really taken the organic community and actually took a huge array of their arguments away. Let's see what he does. This is Rick, 7,000 acres organic no-till. He went from conventional to no-till to covers, now is organic no-till. He saves over $600,000 to $800,000. No more fertilizer, no more pesticides, no more herbicides, none of that. That's what he saves every year. He is no-tilling right directly corn and soybean into living covers. Where did we learn how to do this? I learned from a 70-year-old man from North Carolina. He's been rolling covers since the 1970s. Took his little video, spread it the whole country. Look at this. Those are not cultivators, those are miniature lawnmowers with a little blade, run on hydraulic to get the remaining escape for the weeds. Not touching that surface of that soil. No soil disturbance, as little as possible. 7,000 acres, organic no-till. It's amazing how much money you can make when you don't have to spend it. Now, this is me rolling my cover crops in the back of my yard. Because people say, well, Ray, I don't have the equipment. That's my daughter's diesel Jetta. I am offsetting her carbon footprint. And I believe in animal integration, 2 Rhodesian Ridgebacks. This is when I lived in North Carolina. I had a 1.25 acre lot. I did not use any herbicide to terminate that A-weight mix. None. I hit the cereal rye right at the right time. I focused on the cereal rye. Cereal rye is really easy to terminate once it reaches that dough stage and maturity. And I'm saying, hilarious. I posted that on YouTube because I keep hearing, I don't have the tools. And that's what I love about you, Martin. You did it with the least amount of, now you can use your pickup truck. Go back and forth. Look at that. Now, this is my daughter and my very unhappy wife. She is my down pressure from my no-till plan. Do you see why she doesn't come with me anywhere, John? Luckily, she's such a good spirit. She doesn't say much. She just says, I said, wife, why did you marry me? She says, husband, you're more entertaining than watching TV. So she did that for me because I had to get the drill to work. David Brandt built that for me for my lawnmower. But now I got 155 acres in Missouri, so we're going to do that again, but I'm going to do it on a bigger level. Okay. Yeah. No more riding the planter. She was very nice for me that day. I don't know how I pulled it off, but I did. And so we planted right into that. No herbicide. It's timing. That's the thing. And I learned from Ray Stiers, 70-year-old, and I used to go roll cover crops for him during the weekend when I was working as a government employee. So I'm glad he allowed me to go help him. This is the results. We're doing this on cotton. We're doing this on tomato, pumpkin, squash. We're doing it on all. When you grow pumpkins this way, there's no discoloration on the bottom of the pumpkins. The weed suppression is fantastic. Cereal rye releases these beautiful allelopathic material, cuts natural herbicides. You guys have seen it. How many have seen a walnut tree? Nothing grows under a walnut tree. Do you know why? Allelopathy. They release jogaline. Sudan grass releases sergolone, natural herbicides. There's a whole book called Alleochemicals, Allelopathy, Allelopathy. There's a whole book on that. Folks, it's like somebody was telling me is, we've become producers, but we forgot to be farmers. Farmers have this elegance of knowing what they're dealing with. Case in point, guys. How many of you would get in the plane when you found out that the pilot has no understanding of aerodynamics? Would you get in? Heck no. But we, as farmers, have a very low understanding of how the soil works and ecology. In fact, the word ecology means study of the house. I was in Kentucky. I have to share this quick story. I was in Kentucky, and one of the extension guys says to me, beautiful southern drawl, he says, Ray, I like your stuff, man, but when you said that hippie word, I said, what hippie word was that? Ecology. I go, oh, yeah. There's textbooks, ecology, study of the house. This is what we're teaching you about, infusing life ecology into your farming system so that you may become more profitable. Now, Matt Winger. Matt is located where, Lance?
Southeast Wisconsin.
Say it louder so everybody hear you.
Southeast Wisconsin.
Do you remember the little town? Yeah. Yep. Okay, so Matt came to one of the workshops like you did. Matt was backed up into a corner. Him and his dad separated. He's a dairyman. Had a huge debt load. He didn't know if he was going to make it. He switched to no-till and covers. And I'll never forget when Matt did that. He came to our 3-day school. Matt changed a lot of things on his operation. Let's see what happened to Matt. But of course, during his journey, he had mentors like Tony Pidrick. And we're going to talk about mentorship here, guys, because I'm going to tell you right now, please do not do this by yourself. Do not do this by yourself because you will spend the rest of your lives. Some of you have 40 growing seasons, you young guys. I'll be lucky if God gives me 20 growing seasons. If you do this by yourself, you will spend the rest of your life figuring it out. We just got back from Wisconsin. There's a group of guys, maybe 5 or 7 guys get together and they talk to each other on a regular basis. Think if you have 10 guys in your group, you have 10 years of research demonstration happening every year. I guarantee you, if you do this on your own, good luck. You will spend the rest of your life working. You are dealing with the most complex job in the world. You are a farmer and rancher. Engineering is easy. Working with a dynamic ecosystem is complex. You guys are good at getting logistics. But can you do it to the point that you're emulating natural system? That's totally different. Let me tell you the difference between strategy and logistics. Strategy, you remember the Gulf War? Brilliant strategy. Logistics, because my daughter was in the military and she was in logistics, I had to go look it up. Logistics is this. If you do not get bullets and toilet paper to the men, you lose the war. If you do not get it planted, if you do not get the cover crop terminated, you lose the war. Start small, but do not do this on your own. I'm telling you, we have a grazing group in southwest Missouri. We have an awesome grazing group. We go to each other's farms every summer. I just hosted it. We had 60 people. We asked hard questions. I stood there and told them all my failures. All of them. There's no pride in this one. It's humility. What is the nexus of a regenerative farmer? Humility. The moment you got pride and arrogance, you're not teachable. Pride and arrogance, the word is stupid. Can't fix stupid. I've been there. So that's why it's really important to work. When you talk about these watershed things, I'm going to show you at the end how Wisconsin, with Tony Prittert and some of these farmers, are creating farmer networks. They talk to each other. Because see, working for NRCS, we approached it wrong. EQIP had a great concept. EQIP was intended to go into a watershed and work with the producers. But they forgot this. NRCS never knew what the goal was. They were about throwing practices like a bunch of blind men and blind persons. The goal is always, it's not about clean water. That's the outcome. Mimicking nature is the goal so that we have the right outcome. Please understand the goal. Never forget it. That's the outcome. Outcome, and know the difference between process, outcomes, and tools. Now, look at him, Matt. Backed up into the wall, 2014, he went, changed everything. This was his diesel fuel prices. That's what he was paying for 450 acres, $25,578. Boy, if I turned in the diesel thing to my wife like that, she would flip. Fertilizer, $38,500 on a dairy. On a dairy. They got manure. Diesel went from 2014 to 21, because I called Matt. I said, Matt, throw me some numbers. So he went into his wife, said, please put out the Quicken. Here's the numbers. He went from 2021 to $10,963. He went from 300 hours, tractor hours, down to 150 tractor hours. Maintenance. That's not even counting the fertilizer costs. It's not even, he's cut his fertilizer by 50%. That's not even talk. He's dropped his, it is showing fertilizer. Look at his fertilizer costs. From $38,000 to $10,000. What did he do from that point? Cover crops, no till. That's it. This year, guess what, Matt? I designed him a mix. I said, Matt, why are you giving corn silage to your dairy cows? Why are you paying for corn seed? Why don't you do a mix? Because the moment you grow corn, now you pay for the seed, you pay for the fertilizer, you pay for the herbicides. He says, I don't want to do none of that. I said, why don't you do a multi-species mix? Let's do some Milo in there. Let's do some Sudan grass. Let's do some forage corn. Let's create a mix and don't fertilize it at all. Harvest it, feed the cows. Let's see what happens. I'm in. We're doing it. Okay. Look how long it took. 5 years no-till, 3 years covers, heavy clay soils. Do you see how good and aggregated those soils are? What was missing? Stop the tillage, stop the destruction, feed the system. Changed everything. You know what's so exciting? That's what happens when he hangs around people like myself, because I lead him down a bad path. Because now he's thinking about selling all the dairy cows and raising hair sheep. You know what he told me? He says, Ray, I am tired of working so darn hard and barely making it in the dairy. I said, come to the light, my friend. We will embrace you. He came to the house and said, we'll run hair sheep and people will laugh and mock us. And the ewes bring $350 a piece, $4.50 a pound. We will embrace. Your daughter will be happy. Now his daughter's excited. Now the wife's excited. They're fencing the whole farm. I said, I'm tired of not making money. Let the animals do the work. Think about what a dairy guy does. He hauls the crap back to the field, moves it back and forth. Equipment, moving, the cows do the work. Let the animals do the work. Let the cover crop do the heavy lifting. Changed his whole life. Now, let's go back here. Now, let's talk about Wisconsin. I love that the university is coming along. I think it's beautiful. Let's see what they're doing in Wisconsin. I think Aaron Silva is doing some really awesome stuff.
Hi, I'm Aaron Silva, Organic Production Specialist at the University of Wisconsin-Madison. Weed management is one of the biggest challenges for organic farmers, not only in the upper Midwest, but across the U.S. and worldwide. So to help create a tool to help organic farmers manage weeds in their fields, we've been using the roller crimper. Typically with the roller crimper production technique, we plant a fall seeded cereal grain, usually cereal rye or winter triticale. We let that continue to grow through the winter and into the spring, and then when it reaches the birth phase and adhesis, we crimp over the cereal grain and plant directly behind the crimped cereal grain into the rolled mat, which usually occurs in the upper Midwest and Wisconsin around Memorial Day or the first week of June. But to allow farmers to get into the fields a bit earlier to plant their soybeans, we've been experimenting with another option. And that is planting the soybean into the standing cereal rye at the root stage, waiting another 2 weeks for that crop to reach anthesis, and then crimping the cereal grain over the emerged soybean. So that's what we're out here doing today. We've let the cereal rye reach anthesis. This variety is the variety of rustic, which has reached anthesis right before Memorial Day. We're here on May 25th, and we've crimped over the emerged soybean. This year, the stage of anthesis has corresponded with the soybean growth stage of VC at the cotyledon stage. So you can see through this thick rolled mat of cereal rye. The cereal rye was planted on September 15th at a rate of 3 bushels per acre, about 180 pounds per acre. We can see the emerged soybean. So this has been rolled by the roller crimper filled with water, a 15-foot roller crimper. And despite the fact that this has been ran over with a heavy roller, we don't see any damage to the soybeans. The soybeans have emerged, and the roller crimper has rolled right over them without any bending or snapping of the soybeans at this stage. So planting into the standing rye at boot stage versus waiting for anthesis has a couple of different advantages. The first is to get an earlier planting date on the soybean. We've been able to plant about 2 to 3 weeks earlier than waiting for anthesis for the cereal rye. And that allowed for a yield advantage at the end of the season at harvest. Last year, using this system with 2 different varieties of soybean, we saw about an 8 bushel an acre advantage planting earlier into the rye at boot stage versus waiting until anthesis. The second is that it actually can be easier to plant the soybeans and get good to seed to soil contact. As the rye begins to approach anthesis, we see a greater risk of lodging, and that lodging can make it difficult for soybean planting if the crimping is done beforehand. It can be really hard for the planter to be able to plant through that thick rye mulch. Yeah. By planting earlier, less of the rye is lodged, and we're able to get better seed to soil contact and a better soybean stand. To learn more about this aspect of roller crimping or other aspects of the roller crimper technique, you can visit my website, www.uworganic.wisc.edu, or check out my other videos on YouTube.
Okay, let's see interseeding.
Hi, my name is Matt Moore. I'm an extension soil scientist with the University of Wisconsin Extension. Today we're going to talk about interseeding cover crops into corn. So cover crops are a great management tool for farmers that are interested in improving the soil condition, reducing erosion, and trapping excess nitrate. However, the challenge for farmers in Wisconsin is getting cover crops planted in corn production systems. So there's not enough growing season left over at the end of the year for successful cover crop establishment if you're going to plant after corn harvest. A potential management practice that may work and may be beneficial is planting or interseeding the cover crops into corn in the mid-vegetative growth stage. So we're here at the Arlington Research Station to show off some of the research we've done with planting red clover, rye, radish, and an OP mixture, and to evaluate how well they grow and establish when interseeded.
This trial was established in early May of 2015 with the intent of harvesting grain yield off the corn. The corn was managed for weeds with a standard application of glyphosate prior to cover crop establishment. The cover crops were established at B5 corn, and we utilized a modified no-till drill. This drill was modified so that 4 rows were taken off of the drill so we could drive down through the corn rows without damaging the corn and establishing our cover crops with good soil to seed contact with the use of the drill. The cover crops that we utilize include radish, red clover, cereal rye, and a 30% peas to 70% oats mixture, and the oats and the peas were mixed together prior to planting. These cover crops are established utilizing university recommended seeding rates and depths. The corn and the cover crops were visually assessed throughout the growing season to see if there was any stress from the cover crops and the corn canopy. Neither was shown throughout the 2014 and 2015 growing seasons. This corn will be harvested in a few weeks for grain, and yield measurements will be taken. The cover crops will be assessed for biomass accumulation at the end of the growing season, as well as in the spring, we will evaluate to see if the rye has survived winter. In 2014, we did the same trial and we looked at corn yield and biomass of the cover crop again. There was no significant difference in grain yield between any of the cover crop treatments and our non-treated control that did not have a cover crop. The cover crop biomass accumulation looked really good in the fall with strong measurements on tillage radish and red clover. The red clover and cereal rye were the only cover crops that survived winter. However, cereal rye was the only cover crop that needed to be terminated in the spring at time of planting.
So what have we learned so far? Well, we've learned that the cover crops did establish well. Interseeding the cover crops at the B5 growth stage seemed to work well for the radish, as well as the clover and the rye. Well, what about the short-term benefits that also occur? Future research will focus on evaluating the nitrogen credit associated with planting the clovers and the long-term benefits in soil improvement by planting the radish and the rye, as well as other cover crops. For more information, check out the Integrated Pest and Crop Management website, as well as the Soils Extension website in the Department of Soil Science.
It's pretty cool that the universities are coming around. They're catching on. This is moving in the right direction. It's very encouraging. Now, Lance, this producer, would you please tell them a little bit about this producer?
So some of you guys might know of them. It's Mark and Mike Stokes, pretty close to Chatfield. And you look on the left, Andy Earbox there. So they've been using this rig, I think, for 3 or 4 years. I did a video with them. So they're blowing cereal rye underneath the corn snoots.
That apparatus right here, right?
Yes. As a way to save a pass. At about 40 pounds to the acre. You fill up every 10 to 12 acres, so depending on how their corn's running, every couple fills, or when they're emptying the combine. So it's a 2-man show for about 1,200 acres, I believe they run, somewhere around there. So look to the next, you got the next picture?
Yep.
Yeah, that's just a view from the back. Had to put different wheels in it to get the right rate of ride. Go ahead, one more. Yeah, one more. They did seed, one year I caught them, they were seeding like half of the rate, the corn, half of it was in the snow. So they put them right on the snow.
See the video? So, showing it working?
Right,
That's it. Here we go. So as they're harvesting, they're dropping seed. One of the biggest things people tell me, well, Ray, we don't have time. Once you understand, you guys are brilliant. You'll make it work. You'll figure it out. Especially if your wife reminds you. Why do you think we give the ladies a discount when they come to our school? They get it quicker than the men. In fact, I think if we do cost share anything I think, Angela, I think you need to think about doing this for your cost share docket. Buying a tranquilizer gun for the wife. There he goes. He's going to go tilt, take him down, bring him back inside the house. I think you need to cost share that. Because I'm telling you, every time you go do something, you better think it out. My wife reminds me all the time, why are you doing that? I'm telling you, once I get on that tractor, I don't know if it goes with our genes or something, there's some kind of force, and I start going crazy when I get on the tractor. We have to be very cognizant how we manage that. Now, look at the results. Pretty cool. And you know, one thing I was really excited, I don't know how many times I've been on farms when they start using cover crops. And to see a farmer get so excited for seeing an earthworm on his farm that's never seen earthworms before. That means a lot. But think how sad that is. They should be a common thing through all our farms. Remember how many earthworms per cubic foot did I tell you? 20. Good. Now I'm going to show you an extreme, then we're going to talk about the Haney test. I think we're going to get close to that. Yep, we're getting close. Okay, now, growing up in New Mexico, went to college here in Las Cruces, this is the way they grow pecans. This is the way the professors taught us about how we grow our pecan orchards, walnut orchards, almond orchards. No plants in between. Why did they tell us that? It's going to steal water and nutrients and management. No, you got to treat it like that. It has to look like Mars. That's what I was taught. Okay? Look what's happening now. Josh Bowman, he is actually rolling cover crops in his almonds. Uses less water, more zinc brought up for the mycorrhizae feeding the trees. Less aphid spraying because now the beneficials have a habitat. They mow it when they're ready to mow the seed. When they're ready to pick up the nuts, they mow it so it breaks down. They pick up the nuts. Guess what else they're doing? They're raising hair sheep on the bottom. Ooh, double dipping. Very cool. Very nice. Now, okay, so this section is about giving you the power to get good data so you make good decisions, and it gives you a position of strength. We're going to talk about how you start collecting good data and you start doing your research, your calibration. You do that. You are farmer scientists, or should be. Okay? Now, before we do this, one of the biggest things people have been blasting, especially agronomists, come and say, Ray, talking to another agronomist, Ray, you in regenerative agriculture, you're mining the soil because you're not putting anything back. Have you heard of that, John? Mining, see, we think of the soil like this big factory, like this little bank account. Have you heard that? You remove, if you put in and you remove through the grain, through the stalk, you got to put back. Energy mass balance, like a machine. Doesn't work that way. Does not work that way. And then if they say to me, well, Ray, where are you going to pick up the nutrients? From the air? Actually, yes. Let me show you. For this next, let's talk to a biologist. I think biologists know more about where the plant mass comes from.
Towers over you. But where will this tree get all of the materials it needs to grow? From the soil? From the water? What about from the air? Like humans, plants are made of mostly water. But when you take away the water, where does the rest of the plant's mass come from? If you remove the water from our bodies, you would find that carbon makes up most of the rest of our mass, or weight. The same is true for plants. Humans and animals get carbon from the food they eat, which is often plants. So where do you think the plants get carbon? They get it from the air. The air around you seems empty, but it's not. Air is made of tiny bits called molecules. When you look closer at the molecules in our air, you'll find that it's mostly nitrogen, oxygen, and carbon dioxide. Plants actually absorb this carbon dioxide from the air through small openings in their leaves or other tissues. These openings are called stomata. Once inside a plant, the carbon dioxide is broken down, and some of the carbon ends up in the chloroplasts. Chloroplasts are special cell parts that hold chlorophyll, the molecules that make most plants green. Chloroplasts are also where photosynthesis takes place, which is how plants convert sunlight energy into food. Carbon, water, and energy are used in this process to make glucose, which is a type of sugar. Glucose molecules can then combine to form long chains called cellulose, which are used to build plant structures like cell walls. So the carbon from the air, along with water and energy from the sun, help to make these structures. As cells grow, they divide and make new cells. These new cells are how plants get bigger. The most amazing part of this process is changing air into plant material. This sort of magic trick transforms something which seems weightless and empty into material that has weight and that you can see. From a tiny seedling to a tall tree making seeds of its own, plants grow by pulling carbon out of the air. So in the end, plants really are made out of thin air.
You know how sad this is? I went to college for 8 years and did not know that. Folks, you know that huge corn silage you harvest? That 12 foot of corn? You see those big trees? My wife and I went to California. Most of that is water and air, carbon. Only 5% of that total biomass of that plant comes from the soil. Less than 5%. How many of you have actually went in a whole acre and taken 250 units of nitrogen, because most of it's filler, and you spread it over 250 acres? Even doing it in the small room, what does it look like? 1 grain here, 1 grain here, 1 grain here of nitrogen. Phosphorus, very little. Parts per million. A majority of the nutrients do come from the air. But how do we get those little bit of 5% nutrients to cycle very effectively in our plants? The cover crops. You got a comment, John? Biology. Of course, the biology. He gets another, of course. Now we're getting into this section where we're going to get ready and go to the soil test. Okay, so first I had to show you that to break another paradigm you have. So that corn, that soybean is mostly air and carbon. Oxygen does what you're growing. So that's why sun is so critical here, okay? Now, I'm going to give you a perspective of all soil tests. First, I'm going to pick on the computer models. All computer models are wrong. Some are useful. All soil tests are wrong. Some are useful. The one I'm going to talk to you on is useful. But it's not perfect. Why do that statement? You will never, ever find a one test that tells you all the functionality of the soil. Neither will you find one test of the human body. That's why they do CAT scans, urine, fecal, everything. Why? You're complex. Period. Okay? Now, by the way, you go YouTubers, go and Google There's Magic at the Border by Dr. Brad Joran. I think he's from Illinois. No, he's from Purdue. What he did is, he says, it looked at all the 2-year fertilizer cost of 180 bushel acre, figuring on 180 bushel acre corn and 60 bushel acre soybean. Values at that time is in dollars per 1,000 acres. This is per 1,000 acres, the costs. Assuming 50-cent pound nitrogen, P2O5, K2O. Look at, as soon as I crossed the border from Missouri, 260 to 392. We go to Iowa. Look at the differences all over the country. Why are we all over the board? There must be magic in the border.
No-till versus conventional.
How about crappy soil tests?
University recommendation.
Some universities do not even recommend nitrogen at all. Did you know that? Tennessee does not recommend, give you credit. They just give you a model, that's it. That's what you put out. Now, here's how we go. Many have heard that the Haney test is not calibrated. The Haney test came from USDA ARS, from a researcher who's got a PhD, has been working on years. I met him. What does calibration mean? I will tell you the old soil test is not also calibrated. When they did the old technology, the soil was already destroyed, and they did it strictly in chemistry. Biochemistry dictates inorganic chemistry. If I had to go back to college, I would have taken all kinds of biochemistry. It's biochemistry infects the geology and makes the nutrients available. This test is based on biology. They reign in that soil, not inorganic chemistry. I took graduate chemistry, soil chemistry. What a waste of time if you do not have the right context in putting the microbes first. Who made all the nutrients available to begin with? So do not compare the two tests. They're apples and oranges. That's why a lot of researchers get confused about the test. One's biological. You have to think like a microbe. The other one is chemistry. I use both of them, but do not compare them. Okay. Haney is based on the principles of biomimicry. What did I tell you? If you do not base your science in the foundation of the natural system, you're wasting time. I evaluate everything from a biomimicking nature. If it does not glorify the human body or the creation or the natural system, go away. Don't waste my time. Do not waste. I've already been fooled once. Not again. Okay. Rick, extract. The extract is to figure out how much of the nutrients are going off the cation exchange site. Rick uses the acids of the root. What the plant really sees. The old soil test uses sulfuric acid, ammonium, all these caustic acids, forcing cations off the exchange. Then they run a calibration, and that's how they estimate how much calcium and all the things you need. One is not realistic. The other one is what the natural system sees. That already sets it apart. If you're an awesome scientist, you want to learn about the natural system, you want to mimic it in the lab. They use very sophisticated water analyzers. The Haney test uses sophisticated water analyzers. Why water analyzers? Because the soil runs on water. The microbes are subaquatic. So when you get your soil test, you send it to Regen Ag Lab, they're going to re-wet that soils, and then when they wet it in the molecules of the water, you're going to pick up all those carbon constituents, and those sophisticated machines read it directly. It's like your blood. When they put that needle in there, it's a direct read. I'm sorry, you can't fool it. It is what it is. Same thing with those water analyzers. Okay? Now, the Haney test goes over those 7 parameters. I am not going to explain every one of them. One's respiration, one's extractable organic carbon, that's the groceries. The efficiency of the microbes, extractable organic nitrogen, water extractable organic nitrogen. Notice how I said water extractable organic carbon, water extractable organic nitrogen, and then we've got all these other parameters. The balance of carbon, organic carbon and nitrogen, and the inorganic N and P. You get all this, and then you get a score. Now, the purpose of the score is, now you probably want to write this down because everybody got their form. Everybody, pretty soon, I want you to get this form. We're gonna go over it. I'm only going to go over it once. Okay. What we're measuring, the Haney test, what it measures is the refrigerator of the house. Organic matter. If you ever want to impress your wife, hey, wife, my 1% organic matter is 6,000 parts per million carbon. Ooh, that's a standard, folks. 6,000 parts per million is 1% organic matter. Okay? That's the house. Everybody compares themselves with organic matter, right? Be careful with that standard. I have seen soils that are 30% organic matter and nothing growing in them. Why? What do you think, John? 30%. I thought that was the standard. Low pH, hydrophobic, they shed water, there's no cycling. Those come from bog soils. Be careful the way you look at organic matter. That's the house. Let me give you another perspective. Who cares if you live in a 10,000 square foot home, but you eat hot dogs every day? Life sucks. You impress the neighbors, but you're starving. Right here, folks, refrigerator. That test measures the refrigerator. Water soluble carbon. Okay? Again, I call this the blood sample of the soil. Okay, the current test measures this. Nitrate, nitrogen, or ammonium. Rick's test measures this. All the other 50% of organic nitrogen we've been missing all these years. I never wondered how, I always perplexed. Well, how come all those trees grow by themselves? How come my pastures, I never fertilize them? How come the grass is this tall? Where's the nitrogen coming from? If you run the traditional soil test, who has pastures here, by the way? Raise your hand. Have you done one in a pasture? Did it have a lot of nitrogen or a little?
I've always been told never to test for nitrogen.
Nitrate, nitrogen. What did you find in them?
Can't remember.
Low. Why? Well, how's the grass growing? Oh, it's in the organic form. We've been missing it. I could never wrap my mind. Do you know when I started realizing the soil tests were wrong? 2010. Going around the country, and I said, what the world? These tests are all over the place. It was on Jim Harbach's farm dairy. Corn looked dark green, beautiful, manure, no-till, cover crops. He put another 50 units because of soil test. And I go, what the world? Then I said, something's wrong with the test. Something's wrong. Luckily, butterfly effect, a tornado of change. I got to meet Rick Haney in 2011. He's been working on it, and thank goodness it was a government lab. Now, everybody pull the test. We're going to go through it, and I'm going to show you how.
What about if I grid sample? What tell us about that?
Yeah, I said, okay, with a current soil test, if I grid sample, somebody says, well, Ray, what if I grid sample? Isn't that cool? I said, yeah. If you're using the wrong soil test, you're very accurate of being wrong. A lot of money to be wrong. You're still missing 50% of the organic nitrogen. Everybody pull the test out. Okay? Okay, I'm going to show you how to interpret it because I can't be all over the country, but you can read your own. That's a guide. And there's only one lab you're going to send it to because I do not get kickback from them. But I will not put my name. I'm not going to take risk on your farm if you do not send it to the right lab. There's a lot of people saying we do the Haney test. No, they're not because they not buy all the equipment and they're not following his procedure. If they're not following the procedure, don't call me. Don't ask me to interpret somebody else's test. Here we go. This side, notice the top, indicators, parameters. Every part of the Haney test is listed right here. This is the range, I want to see it, and this is the meaning of each indicator. Here are sampled farms, one in Ohio, pasture dairy, one organic dairy, tillage and covers, no-till. This young man set the standard for yield contest, 318 bushel corn, dry land, only been farming 10 years, rolling cover crops, no-till. That's his, and that's the neighbor's. No-till, no covers, high chemical inputs. We're going to talk about each one. But let's first, I gave you an example, and in the bottom here is my interpretation of the test after reading thousands of them. We have 40, 50,000, hundreds of thousands of samples all over the world. Labs are being built in all over the planet, Australia, going to Europe, going to other places, because the Nobel Foundation, people are building these labs. Okay? Now, notice what I have here. Depending on the ecoregion, I like to see 3% organic matter and above. Does not mean just because you have, I've seen in desert soils with 2% organic matter and the soils are functioning. But that's just a rule of thumb. Now, here's what this one is. Notice what I said here. WEOC. This is the food. Groceries. I want to see over 150 parts per million in your soil test. When you read the Haney test, I want to see 150 and above. Usually, if it's low here, it's going to be low here. CO2 respiration is work. The more I do exercise, the more CO2 I release. How did Rick pick that up? The Russians knew in the 1900s about CO2 respiration. The moment it rains, respiration goes way up. So fertility is dependent on respiration. More food, more groceries, more cycling. I want to see this 200 and above. Percent MAC is the efficiency of the microbes to process the carbon. This here is the ratio of organic N to inorganic N. What does that mean? 1. Okay, so everybody has to be in the same page here. Guys, I'm going to help me here. What's the difference between organic N and inorganic N? What do you think it means? This is critical. All of us need to understand this so that you have an intelligent conversation when somebody says, Ray, what's the difference between inorganic and organic? N.
Is it one accessible and one's not?
One is accessible and one is not. Partially true. Plants can take up organic N too. They can take it through amino acids. But here's what I wanted to hear. Good. You're partially there. One still has a carbon molecule attached to it. The other does not. Everybody with me? Organic still has a carbon attached. The other does not. And it's usually the back end of the process. So you're partially right. It's okay. It took me 15 years to get it. I'm slow. I am. I really am, guys. Please, now this is an important thing, because if you do not understand this, then you understand why your crop is lacking nitrogen. We get caught up because we don't understand carbon to nitrogen ratios. Plants and the soil is always modifying the carbon to nitrogen. Carbon is this, write it down. Food. Food for the microbes. When you say carbon, food, 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 food. Nitrogen builds my body. What did that little video say? You guys are huge. All of you are carbon. When we eat that steak, we're eating protein, proteins, nitrogen. They're connected. Protein, nitrogen, all together. Okay, everybody with me? Nitrogen, body, builds body, cells. Carbon is food. Okay, once you got that, that really helps everything. Okay? Now, I want to see, so you know why this is so important, guys? You know what the first thing I started noticing in the Haney test when I see a really healthy soil? Look at this one with 7.3. 2.6 carbon organic nitrogen versus 1. The ratio will always be higher in a healthy soil. But careful. If the soil is cycling very quickly, depends when you take that soil test. CRP will always have more organic N than inorganic. Now hold on to that, because I'm going to show you right here. Now this number here, organic carbon to organic nitrogen, this is the range of carbon to nitrogen ratio. I want to see that less than 25 to 1. Probably more 20 to 1. I'll probably change that to 20 to 1. Where are we talking? Inside the aggregate, let's pretend we're swimming inside, we're in this little aggregate. Microbes are eating carbon, they're eating nitrogen. If there's too much carbon and not enough nitrogen, you tie up, the crop turns yellow on you. I want to see that 20 and below, 25 to 1. When you see your soil come back, look at that, okay? Now, we can talk the traditional soil test. Now, go across. Now, when you get the Haney test, guess what? You get 2 soil tests in one. You get the traditional and you get the Haney, but you got to ask for the Haney test. You are going to do your nitrogen recommendations by the Haney. This is how you do it. Traditional soil test, look at this field right here. This healthy soil. If I did a regular old soil test that's used all over the country, you only have 14.6 pounds of N. But the Haney says, no, we got the organic N, water-soluble organic nitrogen, the ammonium, and the nitrate. No, you got 72 pounds. Does that make a difference? Multiply that by 1,000 acres. We've been missing over 50% of the nitrogen. That's why when I went into a forest and did a soil test, it's starving for nitrogen. I do it in a pasture, there's no nitrogen in there. Because it's only measuring nitrate, and nitrate is always going to be low in those systems. But where's the organic? So how does the organic nitrogen become processed? Microbes do that. Plants can do this. Hey, I need more nitrogen. Release more exudates, wake up the microbes, they process the organic nitrogen. By the way, fungi can take up amino acids. They have a carbon molecule attached. Oh, also too, by the way, how many have heard the concept rhizophagy? Root eating. Plants are carnivores. They suck up bacteria like vacuum cleaners, strip their outer shell, and use them for nutrients. Recent research from, what was it, Rutgers. Dr. White, write him down. Watch his YouTube. Dr. White, Rutgers. He's worth watching. Hey, now look at traditional P. 61 pounds. Haney, no, you got 78. Now notice how the soil, these two dairies I'm comparing, this guy loves equipment. Loves equipment. 4.5% organic matter, good soils, 152. He's probably doing, he's putting covers. I got to get him credit. He's a pretty good farmer. But the tillage is sending him back. But look at the water-soluble carbon he's got. Look at how he's going backwards. But notice how much nitrogen he's got in his system. But the Haney says, no, I mean, the old test said you got 8.3, but he's got 42. Now look at Russell's 18. Now notice who did the worst. The no-till with heavy chemicals. Soil health score was 3. Now the scores mean this: 0 to 7, so it's poor; 7 fair, 7 to 14; good, 14 to 20; excellent is 20 to 15, 20 to 50. This soil health score was 28. Phenomenal. That's what I expect to see in pasture ecosystems. I've seen no-till like this in 30s. In 40s with covers. Now, here's how you're going to do it. Say your goal is 200 bushel corn. So I say 1 unit of N for every 1 bushel. That's kind of a rule of thumb. I don't know what the university has here. Okay, so you get the Haney test and it says, yep, soil respiration is 20. The groceries is only 200 parts per million. Water soluble organic nitrogen is 20. I need 180 pounds of N for 200 bushel. My soil health score is 8. Everybody with me? Okay, now, look when the respiration and the health of your soil. Double the respiration, double the organic nitrogen. He only needs 40 pounds to reach the 200 pounds, 200 units, to meet 200 bushel. Soil health score is 26. That's pretty darn good. I feel comfortable with that because we've done this on thousands and thousands of farms now. Okay? I do not feel good if you don't take it to this one lab. So where are we going to take it to? I'll show you in a second. Okay, so I'm going to do all these tests. These Earth-4 tests, now when Earth-4 does, it counts nematodes, it counts all those organisms. Regen PLFA is phospholipid fatty acid. That tells, all of us have phospholipid fatty acids. And so what it tells you is what's the number of those organisms in that soil. And then the Haney and the traditional. So we do no longer tissue, but yeah, is it tissue? Which one was it, Lance? SAP. Let's erase that, put SAP test, check strips, water sensors. The young man that did 117 bushels, I'll tell you, he's got water sensors on his soil. Slake test, infiltration, shovel, all these tests. You calibrate your farm with this tests, all of them. Okay, let's pass here. Now, how do we do the soil test? Do not collect the soil test until the temperature is over 55 degrees. 55 soil degrees temperature. Why? Microbes aren't doing their business. If you collect it when it's real cold, your scores may be too low. It's going to penalize you. Now you can do water extrapo. I wait until 55 degrees. Just get about ready when you're going to apply your fertilizer out there. Some of you say, well, logistically, I can't do that. Do the best you can, but be sure, because sometimes, how many of you split your nitrogen? How many people split their nitrogen? So you're ready to put a little bit up front, then wait a couple of weeks, then you get ready to put your last slug, then you do your test. Okay? Here's what I do. Let's take this test costs about $60. I've had farmers complain, well, that's a lot of money. Please do not call me. You're not going to spend $60 to save thousands. Please don't call me. So this is how you collect the test. I use a 4-wheeler. How many have a soil probe? Okay, here's what you do. If you got a sandy soil and you got a clay soil, treat them differently. But if they're all the same, that's cool. Don't worry about it. Try and take 30 to 40 cores, as much as cores you can take for a 40 to 80 acre field. Mix it in a 5-gallon bucket, put it in a 1-gallon Ziploc. That's one soil test. 80 acres. 50, 60, 70 core, mix that 5-gallon, 1 Ziploc, good, send it. That's one soil test. If it's sandy here, clay here, do them separately. Why? Why do I like to delineate between sandy and clay? I don't worry about the silt. If it's very much silty or silty clay, treat it the same. But sandy, I like to treat it differently. Why? Biologically, and by the way, microbes fit into the pores of the sand. They eat the organic matter quickly. So I have to be very careful. But here's what the neat thing. If you have sandy soils, you know what helps me hold and allows my sandies to hold more water? Cover crops. Microbes start coating the sand. Now I can hold nitrogen. Those super molecules now will let me hold water more. I can hold nutrients more. It changes my sandies into more a better manageable soil. Now my clays get opened by the microbes because the plants leak acids, disperse the clays open, coats the clay particles. Other thing about clay, why does organic matter last longer than clay? Because you have to look at clay under an electron microscope and the bacteria cannot get in there to eat them, eat the organic matter and the glues. Everybody with me? I can see some of you going, Ray, I'm done. Okay? Now, this is where you're going to send your soil tests. I do not get money from them. My reputation is on that lab because we trust Lance. Dr. Rick Haney now is retired and helping Lance get that soil test better. As soon as other labs do it exactly like Rick says and buys the equipment, we will tell you about the other labs. I'm just not going to stand behind them. The equipment's got to be done right. Those water analyzers are $100,000. There's a lot of things, the methodology is critical. So that's why I really, everybody got the writing down? Regen Ag, so you got the website, and that's where you're going to send the samples to. Okay? Transition to what?
Farmer panel.
Oh, we got a farmer panel. Super cool. Okay.
Soil samples, yeah.
Oh, thank you. Appreciate that. Oh, there's one more test you're going to take. It's called total dissolved nutrients. Total dissolved nutrients. What is that? That will let you know how much phosphorus, potassium, zinc, and all that. You use very strong acids. Go to 0 to 12, then you'll know how many nutrients you have in the top 12 inches. Do you know what's a common thing we're finding? People will range anywhere from 19 to 40,000 pounds of phosphorus in the soil already. It's just not available. T, total dissolved nutrients. Get the Haney and get the total dissolved nutrients. Please, when you write label down and you send the soil test, you either tell them 0 to 6, 0 to 12. You've got to be very specific because you don't want to dilute the answers, okay? Good? If you have problems with this session, call 1-800-LENS. Okay, panel. Okay, guys, that's that session.